Hello everyone, welcome back to our another data analytica video. So in today's video we'll talk about data visualizations. And we know that data visualization is not just about making charts, but it's about telling stories with data. But with so many chart types available, how do you know which one to use and when? So in this video, we will explore most common types of data visualizations from bar charts to heat maps and then learn the right use cases for each. So you will see how to visualize comparisons, trends, relationships, compositions and distributions. So you can pick the perfect chart for your data every time. And by the end of this video, you will not only understand how to create visualization, but also why they matter. So let's get started. I'm here again in Databricks Free Edition, and I'll create a new notebook. And I'm going to name it as a visualization guide. Okay, and so this actually mainly the libraries used are Matplotlib, Seaborn and Plotly, and I'm going to create or generate charts mainly using Plotly, because you know that Plotly is more of an interactive type and it's actually gaining more popularity these days. So I'm going to use more of a Plotly charts. So first of all, we need to import all the libraries that we are going to use. So Matplotlib .pyplot, we'll call it PLT, and then like I mentioned, Seaborn as SNS, and then pandas to create the data frame, and then we have numpy as np, and also the plotly .express as px. Okay, and first of all we need to create a sample data set which we will use while generating visualizations later. And let me use 42 because we would like to generate the same data set again. So I'm going to use np.random.seed, and let's say we're going to create a data frame with 100 rows and 5 columns. So df is equal to pd.dataframe, and here, so the first column is going to be category, okay, np.random.choice A, B, C, okay, and then we're going to have another column value. So the value will have random values from 1 to 100, and 100 here is exclusive, so 100 numbers and exclusive of 100. So, and then we'll have another column with x. Okay, so while generating x, because we're going to show lots of distributions, that's why I'm generating this column x. So here we are going to generate 100 random numbers, 100 random numbers, but from standard normal distribution. So standard normal distribution is usually with mean equal to 0 and standard deviation is equal to 1. So values will be centered around 0 and numbers close to 0 mostly. Okay, so x is going to be np.random dot rand n of 100. Okay, likewise we are going to generate another column y. Okay, so y also similarly we will have generate 100 random numbers from normal distribution, and here we will actually have will increase the spread by 50. I'll show you how we can do that, and also we will move mean by 20. Okay, and so y is going to be np dot random dot rand n with 100, and then we will have it like I mentioned, the standard deviation we'll spread it by 50, so we'll have to multiply by 50, and then we will have a mean up by 20. Okay, so here we are with y, and then the next column that I'm going to use is create is date column. So date column we will have 100 consecutive days from 2025 0101. Okay, date pd dot date range of 2025 1 and then periods is going to be 100, and then frequency going to be daily. Okay, so let's print and see how our data frame looks like. Okay, so here we are. We have a category value with CABC as its values, and then we have a value column, and then x and y. X, you can see that the values mostly closer to from a -1 to 1, and then we have y with a little bit of spread. You can see that it's closer to more than 50, and it is increased value. And then we have date starting from 2025 01 the 1st of Jan. Okay, so we have the data frame ready. Now let's move to visualizations. Okay, and the first visualization that I'm going to discuss or that I'm going to show is bar chart. So bar chart, you know that it's mainly used for comparisons. So to compare between, let's say, different categories. So I'm going to mention different use cases comparing categories, and then also ranking and distribution of discrete values. So we know that we have already seen some cases before, and also you might have used in your projects. So it's like mostly for comparing categories and also ranking distribution of discrete values. So I'm going to show an example. So what we are going to do is we will compare average values per category. Okay, average value per category. So df mean. So I'm going to create a mean data frame, or the df mean, which will use group by category, and then we will keep s index false, value, and we'll find out the mean. Okay, and then we'll use a fig is equal to px dot bar. So this is how it's done in Plotly. So when you need to create a bar chart, px dot bar, and here the data frame that we're going to use is df mean, and then x is going to be category, and then y is going to be value, and we will give a, so this color discrete sequence is kind of like bar colors, how you would like to color discrete sequence is going to be of, let's say, sky blue, and then okay, maybe it's better if we line by line, if we show it. Okay. And the title, let's give title is equal to average, so compare average value per category. Okay, so I think now we can try to show this figure, not show. Okay, now let's run this. Okay, I think I forgot an T. It's a typo. Okay. So here you can see that it's very easy to identify or compare between average values of categories, and here you can see that B having the highest average value 52.55, whereas the next one in line having like 48 for A and then 46 for C. So bar chart is the best way to compare between different categories and to see how different values actually compare, or like it's easy to compare between different discrete values. So that's why this is a case, this is an example where we use a bar chart, so mainly for comparison purpose. So the next thing that we are gonna see is, next chart is line chart. So line chart, like you know that it's mainly for trends. So over time, to see what were the changes or how the value actually has been changing over time, different time period. So it's easy to say use cases, time series, or showing changes or trends over time. So this is mainly when these line charts are used. Okay, value over time. So this is an example that I'm going to do is actually to see how this value changed over time. So we have a value column and also we have date column. So let's see like how this value changed over that time period. Okay, so how we are going to do it? Fig equal to px dot line. So this is for line chart. df, and x is going to be date. Okay, and then y is going to be value. Okay, and title is going to be value over time. Fig.show. Okay, let's run this and see how. Okay, so this is you can see that this is a way to actually see how the values from varied, or how they change from Jan to April, as you can see. So you can see that the values have been very inconsistent, as you can see, like when it changed. It's not like a steady rise or steady fall. So that's actually the first inference that you can actually make from this line chart. But it's really easy to actually see what has been the trend over time. So yeah. So that was about line chart, and line chart is mainly for trend or showing changes over time. Okay, so let's move on and let's go to the next chart, which is scatter plot. So scatter plots are usually for showing relationships between different let's say like different columns, let's say x and y. So it can be, oh sorry, I missed SA. Okay, so scatter plots having use cases like to show the correlation between one or two variables, and then outlier detection. It's actually easy to see what are actually the outliers, or how many outliers you can detect, and then also it shows you clustering patterns. So these are the main three use cases: correlation, outlier detection, and clustering patterns. And today so I'm going to show you an example of scatter plot where it's usually x versus y columns with category and value. So it doesn't have to be always two variables or two columns, but it can be more than that. So I'm going to show you how we're going to do it. So fig equal to px dot scatter. Scores px dot scatter is for scatter plot, and we'll use df, and x is equal to x, and then y is equal to y. And then we, for coloring of the bubbles in the scatter plot, so we'll use category, and its size is dependent on value. And then we have let's say like while hovering, it can show the hover data. So it's not the hit, it's hover date data is equal to date. Okay, and also we can have its title. So using the update layout, so title is equal to, let's say, x, or a scatter plot of x versus y with category. Okay, with category and value. Now let's try to show that. Okay, so here is you can see that x in x-axis, y in y-axis, and then we compare using different categories and values, and you can see that the size of the bubbles, so different categories have been colored in different ways. And then we have we see that like actually it's mostly the values are clustered around here, so maybe outlier or something. So here it's usually like a B having a different value than for actually X, compared to other categories. So and you can see that the bubble size has been actually shown here using the value column. So the higher being the value, its bubble size is going to be a little bigger. So here you can see that. Yeah. So that's how this scatter plot has been actually used in this case. So mainly to see the correlation, to mainly to actually like see how X values stand with respect to the Y values. And here we have two more columns that we compare or that we show with. It's a category and value. So yes, that was about scatter plot, mainly for the correlation and also the outlier detection and then clustering patterns. So the next thing that we are going to do is, or the next visualization that we will see is histogram. And histogram is mainly for distribution. So the use cases: understanding data distribution, skewness, and let's say like frequency. So these are actually like bar chart for comparison. Histogram is mainly to see how the data has been distributed. Let's say standard normal distribution, or what is actually the skewness to which range actually the values mostly fall into, and what are actually the frequency. So let's try to understand the distribution of values from the data frame using histogram. So for that we will actually create a histogram. Okay, and we will use df, and X is going to be value, and then we'll have, let's say, 10 bins. So we can specify in how many bins we would like to see the whole value value range. Let's say like in now I have actually given n bins equal to 10. Okay, and then we can specify the color of bars. So color discrete sequence is equal to, let's say, here I gave purple. Okay, and then title, let's say distribution of values. Okay, and we can also let's say update the layout. So mainly to update the title of x-axis and y-axis. So fig dot update layout, x-axis title is equal to value, and then y-axis title is equal to frequency. And then bar gap, let's define as 0.2. So between space between bars. Okay, and I think we're done. So now let's use fig.show to see the chart. And here you can see that this is actually the distribution. So here we can see if you count it, so there are actually 10 bins, and in the values have been actually shown or distributed among these 10 bins. And we can see that the 0 to 10 range having, or the 0 to 9 having most count with 13. And then this is actually the frequency. So how many values do actually fall in these bins. So it actually shows you the frequency. And here you can see that what is in which range the most of the values are in. So, and also we have a closer number in 90 to 99. So there is no such squeeness, as you can see, like it actually falls in mainly 0 to 10 range or 90 to 99 range. We cannot say that. So this is about the histogram, and histogram is looks like a bar chart, but the purpose is mainly for to see the distribution, the frequency. So when you would like to show the distribution or frequency of the values, histogram is actually preferred over a bar chart or something. So yeah, so that was about histogram. And now let's move to the next chart type, which is actually box plot. So box plot is, I know, like it's actually quite famous to show the spread and outliers. So to see like how many outliers, to see the interquartile range, so to compare distribution across different groups, mainly to spot outliers. So let's say use cases, if I say it's actually comparing distribution across groups and also to spot outliers. So how we are going to do it, we'll actually like take an example. So we will see the spread and outliers by category. Okay, and fig is equal to px dot bx box. So box is for box plot, and we'll use df. X is going to be category, and then y is going to be value, and color is going to be category. Then we have color discrete sequence. Let's say so we'll use a palette, so which is actually px dot colors dot qualitative dot set to. So this is another palette that I'm going to use, and then we'll give the title. So title is, let's say, box plot and spread and outliers by category. Okay, so that's it, and then we'll show the fig.show. Okay, so now let's see. Okay, so as you can see, we have now box plot. So box plot, I'm not sure many of you or like all of you would understand how to infer results from this. So in order to do that, I can actually help you. So these are actually whiskers. So this the one that you see here, and this is actually box. So we have box and whiskers, and because this is quite interactive Plotly one, if you actually just hover over it, you can see that it actually shows like what it means. So in the topmost, it's actually show you the max value, and then you have a Q3 quartile 75 percentile range, and then you have median, and then you have quarter one or the 25 percentile range, and then you have the lower or the minimum value. So when it comes to a box plot, so we have a bottom whisker. So the bottom or the lowest value will actually give you the min value, or it can be 1.5 into interquartile range IQR below Q1. Okay, so it can be the lowest value that's not an outlier. So the bottommost part, or this whiskers, that whisker area that you can see. And then we have a box. So when you move up from the bottom whisker, here you have bottom of box. So that line that you can see, and it is actually Q1 or the 25th percentile. So what it tells you is that 25% of data lies below this value. Okay, and then you have a line inside the box, so which is actually for median, so 50th percentile, and which gives you the median value of the data that you have. And then we have top of box. So top of box is usually for the Q3 or the 75th percentile, which actually tells you that 75% of data lies below this value. Okay, and then you have top whisker. So like bottom whisker, you have max value, or let's say 1.5 into the interquartile range above Q3. So it's actually highest observed value that's not an outlier. Okay, so this is how you actually read this box plot. And so like we have seen, so if you look at this, the median value of category C lies near 40, whereas the median value in category A is actually closer to 50, so it's 51. And then we have for the category B, it's 52.5. And then if you look at the whiskers, the top whiskers or the topmost of the max range is actually different, also different for A, B and C, whereas actually the max value for the A is actually quite lower than that of a B and C. And likewise B having the lower fence, or actually the minimum value at 1. So this is to see like how this interquartile range falls for each different groups, so in this case different categories, and whether we have some outliers, so yeah, and how the spread of values between different groups. So box plot is quite useful to actually see this different the quartile range values of between different groups. So that's why we usually use this. And that's it about box plot. Now let's move on to the next visualization. So next visualization is actually heat map. So heat map is mainly to show the correlation, but it's a correlation matrix, I would say. So you know that like matrix. So we had the scatter plot to actually show you the correlation between different variables or different, so two columns, let's say, and in this correlation matrix it can be more than two, and it actually usually depicted, or it's shown in using the numerical values, which is really easy to see what is actually the correlation coefficient or correlation value between two different variables or two different columns. So I'll show you that, and let's say let's write use cases. So use cases is actually to show the relationships among multiple variables. So it's, I would say, this mainly useful with its numerical value kind of a structure, which is really easy to find the pattern, whether it's a positive correlation, whether it's a negative correlation. So heat map is usually very useful to see the correlation between multiple variables, so more than two, let's say. So let's see how it can be done. And here in our data frame, we are going to find out the relationship between x, y, and value. Okay, so we will first create a correlation matrix data frame. So that's going to be x, y, and value, and we will find the correlation values between them. And then the next thing that we're going to do is, so we are going to use this heat map. So I'm show, and then we will use the correlation matrix, and then text auto is equal to true. And then the color continuous scale is going to be red, blue, and then we will have light blue or something. So I'm going to show you RD, BU, and R. So this is kind of like a cool warm equivalent, I can see. Okay, and then we'll give the title, which is heat map. Correlation matrix. Okay, and the next thing that we're going to do is figure out show. Okay, so here is actually okay. So now let's see how the heat map will look like. Okay, so here okay, so if you are quite new to heat map, so let me show you how to actually interpret a heat map. So in order to do that, let's say if you take the values, so the +1 shows perfect positive correlation. Okay, so that actually they move together. So if you look at like x, y, y, and value, because they're actually the same, and you can see that they have the perfect positive correlation, because of course they're the same. And then we have 0. So 0 actually tells you that there is no correlation between those variables, so no linear relationship. And then we have -1. So -1, what it tells you is there is actually a perfect negative correlation, which tells you that they move in opposite directions. Okay, and if we look at the colors, if we actually try to see what we have in this chart, we know that we have like it's not, if you look at the positive numbers, it's not close to 1. So we don't have an exact perfect positive correlation or strong positive correlation. And if you look at the negative numbers, that also it's quite far from the -1, so, or the -1, so which actually tells you that that also doesn't have any chance of having a perfect negative correlation. So, and if you look at those values have been actually gradiently colored. So how to read those colors is actually, you have red. So red actually shows you high positive correlation. And then you have blue. So blue actually, like when it gets darker, so that means you have more of a negative correlation. and then you have, let's say it's a white or a light blue. So here, as you can see, it's a more of a light blue, lighter versions here and light blue, so which actually tells you that there is a very weak or no correlation. So yes, that's it about okay. So that's it about how to read this, and you can see that here we don't have any strong relationship, as you can see, between these different variables. And with a value x or value value x having a little bit of a negative correlation, and then value x and y having a lighter or weaker negative correlation, and even the same case with value y, weaker positive correlation. So yeah, so that's more of a correlation metrics or this heat map. And now let's move on to the next chart, which is actually pie chart. So pie chart, of course, is quite widely used, and it's quite I think like a very common kind of a chart. And you know that it's mainly, whether it's a pie chart or a donut chart, it's usually used to show the composition. So how the composition of a particular column, how the values have been actually showing proportions. So let's say when it comes to use cases, so it's usually to show proportions or percentage share. So for that, these pie charts are mainly used. Okay, and when it comes to the category, so let's say like we're going to show an example of this pie chart, and for that we need to actually find out how the category values have been composed, or how they have this proposition between categories. So category composition. So for that, let's just create a new df cat where it's df category dot value count. So we'll actually count the values, and then we can reset index. Okay, and then df cat columns equal to category count. Okay, and then the fig equal to px dot py. Df cat is something that we're going to use, and then names is going to be category, values going to be count, and then title going to be category composition. And then colors, we will color it according to category, and we're going to use color discrete sequence is equal to, let's say, okay, we already getting suggestion px.colors.qualitative.pastel, and we'll use pastel. Okay, and fig.show. Okay, so now let's see how the it's giving an error. So okay, color, it's colors, not colors. Oh, sorry, wait a minute. Okay, see color equal to category. Values is going to be count. Okay. Yes, I realized the mistake. Okay. So now we have, if you look at the category composition, if we have different these pastel colors, the sequence have been colored for different categories: yellow for A, and then B, green for B, and then orange for C. And I would say their composition is quite distributed fine, or composition if you look at it, category A having 33%, B having little higher with 36, and then C having 31%. So pie chart is actually the best way to see the percentage of distribution of values or the composition of values for a column across different categories or groups. So yeah, this was a use case, and as you can see, it's very easy to figure out the percentage composition from a pie chart. So yeah. Okay, so now let's move on to the next chart, which is violin plot. Okay, I'm not sure, this is honestly, it's not so commonly used, or I would say it's not so widely used, but it's really a very important chart, or when it comes to the distribution and density. And I can show you how it is actually different with respect to the box plot that we already saw, and how it can be really useful in this case. So distribution and density. So the use cases are going to be when we need to see need to compare both spread and density. Okay, so let me show you. I think it can be easily understood using an example. So when let's say distribution by category. So this, we already saw this kind of distribution using a box plot, right? So how we are going to do it is actually px dot violin. So this is for the violin. Okay, so violin plot df, the data frame that we're going to use, and then x is going to be category, and then y is going to be value. Color will be according to category, and then we have color discrete sequence, which we will use px dot colors dot qualitative dot set 1. Okay, and then we will have box is equal to true, and then points, we're going to show all points. Okay, so box is equal to true is to actually show the box plot inside violin. So show box inside violin. Okay, and then title is going to be violin plot and distribution by category. Okay, and then fig.show. Yeah, so this is actually the violin plot, and when it compared to the box plot, which we already have it inside each violin, and I can say that it's actually much a comprehensive way, or actually like much advanced way to see the spreading or the distribution of values. As you can see, like it is actually shown here, and then here we have actually more values, and then it's wider here, and then we can see the interquartile range and everything. So it's very useful when it comes to see the distribution. So how to read it? It's just that when it's wider areas, so more data points, or let's say common values, and when it comes to the narrower areas, fewer data points or less common values. Okay, so that's how you can read this. And here itself, like you can see that when you actually need to just see the interquartile range, the outliers, etc., so box plot is fine, but when you need to actually see the spread of values, it's much better. And here you have like more it's actually quite in a way like an advanced way than the box plot. Yeah, so yes, that's it about the Violin plot. And now let me show you the last, which is pair plot. So pair plot is like, I would say, histogram, so which is usually to show the relationships between multiple variables. So it's like a grid with scatter plots and histograms. And then you have, let's say, like we can write the use cases, which is usually, of course, like histogram, used to explore relationships between multiple variables. Okay, and here we have, let's say, I'll show you an example. So relationship between x, y, and values. So I'm going to use Seaborn, so SNS pair plot, and df. So we're going to use x, comma, y, and then value. Okay, and we'll give it as a title, pair plot, multivariate exploration. Okay, so and then y equal to 1.02, and then plot dot show. Okay, so this is actually a pair plot. So it shows you the relationship between x, y, and value. And when it's compared to what we had using a heat map, so it does very same thing to show you the relationship between so if you look at this histogram, so in histogram we have how the values have been distributed, whether it's a normally distributed or not, and then we have scatter plot to actually show you the how the values are actually between, let's say, like this x and then y. So yeah, that's how it's shown. So it is I would say like visually a little bit more advanced than the heat map, which actually just showed you in numerical values. So how to read this chart? It may look a little bit complex, but we have already covered histogram and scatter plot before, so it's easier to read because this actually has those charts. So let's say when it's diagonal with bell-shaped histograms, then it's actually in normal distribution. And if it's scatter plot with upward trends, so that shows a positive correlation. And when it's a scatter plot with no clear pattern, then it's a weak or no relation. So I would say, as you may already seen using a heat map before, we don't have a clear pattern here. It's not going upward or downward. So it's actually, it doesn't have any strong correlation between these variables. And then if we have clustered scatter plots, then it actually has a categorical grouping effects, so which also we don't have. Okay, so let's say I have already tried to compare between heat map and pair plot. So when I list what are actually the use cases or the pair plot advantages, let's say it's more visual and it's more detailed. Let's say it's great for exploring data patterns and relationships early in let's say exploratory data analysis, so or EDA. And when it comes to heat map, is more of a compact, right? You can actually see the numerical summary, and it's great for seeing linear correlations at a glance, especially when there are multiple or more variables. So in summary, it can be said that use pair plot for exploration and heat map for summarization, let's say. Okay, so this is a kind of a comparison between pair plot and heat map. Okay, so the same thing can be done using Plotly, but because we already imported Seaborn and we didn't actually use it much, so this pair plot I tried to create with Seaborn, and it can be done using Plotly, where it's a little bit differently called. It's called scatter metrics, but it will actually show you the same thing. So yeah. So I think it's time for summary because we have already seen around 9 different visualizations which are actually very widely used, and it's very important to know in which places or why they are used, when they are used, so that we can really improve the storytelling part of the data analysis. Yeah. So it's time to have a summary. So bar or column charts to compare categories. Okay, and line charts is to show trends over time. And then we have scatter plots. So it's actually to show relationships or correlation. And then we have histograms, which is actually to show distribution of a single variable. So like we have seen for the values, where it actually we created n bins, the 10 bins, and we saw its distribution. And then we have box or violin. So violin is a little bit more advanced case. And then we have, okay, this is actually to compare distribution across groups. So it's a bit different when it's compared with a histogram, which is usually to distribution of a single variable, and box or violin is actually to compare distribution across groups. And then we have heat map. So it's actually to show to see the visual correlation metrics. And then we have we saw pie chart or donut chart. So for composition. And then we saw pair plots, so which is kind of a heat map, but mainly for multivariate analysis. So like in EDA, you can use this. Okay. So I will be, of course, having this added to the Git profile, and where you can, of course, later view this, or whenever you would like to see the visualizations guide or as a tool to really understand which visualization to use. So I think we have now come to the end of the session or this video, and I hope you found this useful, and you'll be able to, you might have now understood when and where to use this different charts. So please let me know your comments, and thank you. So let's see you in the next video. Thank you. Bye.